I've been asked to come here to talk about essential security patterns, but Hamish also told me to have fun. So I thought I'd start off by telling you a bit about this startup idea that I've had. And it came to me the other week when I was sitting in the park during my lunch break and I was eating my sandwich, and it was a really boring sandwich. It was a bit plain. It needed a bit of something to give it a bit of kick. So I had a brilliant idea. What if we created an app that allowed people with the push of a button to be able to order pepper delivered to them wherever they are? And I'd actually like to take this opportunity to invite all of you to come join my team and help me as we build this out. Now, I know you're looking at me and you're thinking, this is crazy, why are you going to be successful? Well, to start with, I'm going to outsource my development so we can move faster. That's going to bring its own challenges, but it means that we're going to leave it up to the experts to help us build this out. We're going to run using a lean startup methodology. So we're only going to be building out the minimal viable product. We're only going to build out the features that we need when we need them so we can test the idea and get it faster to market. And we're going to keep our costs low. I don't want us wasting money on fancy things like Pepper uniforms or anything. I just want to focus on what do we need to do to get Pepper to our customers faster. And as we're doing that, I'd like you all to think about security. All of the stakeholders involved with our Pepper as a Service organization are entitled to security. For our customers, it's embarrassing when you're caught without Pepper, right? So we need to make sure that we're keeping that information safe and secure. For our Pepper providers, we need to think about, we're going to be tracking their location so we can route Pepper better. And then for ourselves as well, we've got some pretty proprietary Pepper programs that we're going to be running online. And so we need to think about how are we going to protect our intellectual property. And for us here at Pepper as a Service, it starts with our culture. So as you can see, we're quite a small team. There's not many of us involved in this endeavor. And we're going to have to be putting on lots of different hats, doing lots of different roles. In the early days, we might be out there delivering the Pepper ourselves. But one of those hats that I want everybody in our organization to wear is that of a security person. We don't have a dedicated security person within our organization, so that means that all of us need to be thinking about security as we build out additional features. And when we build those features, we're used to an idea that a feature isn't complete until it's tested and in production, but I want to take that a step further. A feature isn't complete until it's tested and securely in production. So when I talk about putting those features securely in production, we're not adding that security later as a separate feature. Security is baked into every feature as part of the requirements. And when I talk about security, what am I talking about? Well, to start off with, we need to be building within a secure environment. Once we've got that secure environment, we want to ensure that we're separating out our duties, that we're taking deliberate actions when we're doing different things within our environment for different roles. And we also want to think about, once we've got those controls in place, how do we monitor that those controls are working? And if there should be an issue in the cloud, how do we get early detection of that so we can take action? And once we've got that secure foundation in place, we can then look at how can we build our secure application on top of that. So let's start with our secure environment. Probably not a surprise to you that I'm going to choose AWS as our provider for building our Pepper application in. And when we sign up for AWS, one of those first things that we get, or rather the first thing that we get, is a root user. And that root user in our AWS account can do anything. So it's really important that we add multi-factor authentication to our root, and we add multi-factor authentication to anybody who has administrative privileges. What that means is that a username and password is not enough to get into the system. We also need a third token that we need to be able to verify that we are who we say we are. And then once we've added multi-factor to root, we want to throw that away. We don't want to use root as part of our day-to-day tasks. Firstly, because that root is a very powerful user, but also because if we share those credentials around, when we're making changes, we're not going to know who it was that actually made that change. We all need to be using our own accounts, so we've got a proper audit history of what happened in our environment. And ideally, we want to be federating our identity. And what that means is that we're using an existing identity store within our organization. For us at Pepper as a Service, on your first day, you would have received an email account to log in so we can send you emails. And the first thing we're going to do when you leave is we're going to remove access to that email. So if we can use that same store of identity that we use for our email provider to access AWS, we don't have to have two separate stores that we have to keep in sync. We don't have two different business processes for managing our sets of users. And as we're federating out our identity, I want us to think about how do we ensure that we're applying least privilege. When we're assigning a role to somebody to allow them to work in our environment, how do we ensure that they've only got the minimum set of privileges that they need to be able to do their task? And then lastly, the other thing I want us to consider is to disable our public buckets. Within Amazon S3, we can upload objects and make those available. But we probably want to think very carefully about how we make those objects public. So now within AWS, there's a box we can tick that's going to block public access for us. And then we have to take very deliberate action when we do want to make files public. And with AWS, we don't just have to use one account. We can set up multiple accounts to do our work in, and we can use different accounts for different purposes. And each of those accounts acts as then a coarse-grained security boundary for us. The top account that we want to deal with is an organizations account. That's going to be the root for our organization. And within AWS organizations, we can invite existing accounts to join our organization, or we can create additional accounts within our organization. And from organizations, we can then apply control policies that can limit down and scope down what we can do in each of those accounts. If you want to bring one of your accounts to us, what I'd recommend is we start off with that as a sandbox or some sort of legacy account. And that's where, I don't know exactly what we're going to build to get this Pepper service off the ground, but we can play around in Sandbox, we can try new ideas, and we can see what works. And we've then got a set of core accounts here that we need to deal with. So we want a security account where we can put our audit logs, where we can put secure encrypted backups. And with our security account, the only people who should have access to that are those that are wearing that security role within our organization and taking deliberate action to put that security hat on to do so. And when they're doing that, that should be locked down and read-only. We only want machine-written information in there, so that way it can't be tampered with. Another core account that we're going to deal with is some sort of shared services account. As developers, when we create new features for our Pepper service, we're going to check those into some sort of source control. Ideally, we want that automatically built and then put out into other accounts for each environment. And then we create a separate account for each environment. Now, initially, we're just starting with Pepper as a service, so we're probably only going to have one set of accounts there. But if we decide to move into other areas, I don't know, I've been thinking about maybe mustard would have made my sandwich better too. We can put those out in another set of environments. And we can start to scope down in each of those environments and lock it down further. In development, sure, we want to get in there, we want to fix things, we want to change things. But by the time it gets to test, we want to be deploying in the same way that we're going to deploy into production. So we need that to be read-only so we can get those logs out. And then in terms of best practice security, we want to keep our users away from data. So nobody should have access to that production account at all. Should only be able to automatically deploy our application in there. So we've looked at a couple of ideas here. We've looked at how can we start by building a secure foundation? What are some of those initial first steps? And we've looked at how we can separate out our duties, both by assigning least privilege when we do the federation of identity, but also by creating multiple accounts and using those different accounts for different purposes. And everything that we've spoken about so far doesn't cost us anything more. So we're doing this in a way that's cost effective and it's an efficient use of our time because it's I've got some instructions later that's going to show us how to set all of this up. So what's next? How do we make sure that those controls that we've put in place are working? How do we monitor this? Monitoring is important so we can see that state of our compliance controls, but also to give us an idea of what's happening within our environment. To start with, I think we should look at AWS Security Hub. Security Hub allows us to have a look at what alerts are happening across our accounts and can also do some compliance checks. And it's going to get those alerts from a number of sources. It's going to look at Amazon Guard Duty, which is a machine learning product that understands the baseline state of our account and can then tell us when we're deviating from that. For example, it looks at DNS logs, it looks at VPC flow logs, which are like network flow logs, even if we don't have those turned on. And it also looks at CloudTrail. It turns out that the WS in AWS stands for web services. And that means that everything that we're doing, even if it's through clicking around in the console, is going to hit an API. And when we hit that API, most of those calls are logged in CloudTrail. So what that allows Guard Duty to do is it looks at what is the normal pattern of behavior for our users in CloudTrail, and then can alert when we're going outside of that normal. Say, for example, one of our developers tries to escalate their privilege and assign themselves administrative rights. GuardDuty can give us an alert that that's happened. The other sources that Security Hub looks at is it also looks at Amazon Macie, which is another machine learning product that can look at identifying potential PII, personal identifiable information, in our S3 buckets. And it can also identify possible data exfiltration. And then lastly, Security Hub also looks at Amazon Inspector. And Amazon Inspector can look at the network reachability of our EC2 instances, as well as possible CVEs running on our EC2 instances through an agent running there. But the other piece that's going to be really important for us with Security Hub is it can also add in compliance checks. For example, the Center for Internet Security puts up an AWS Foundational Benchmark, which is a series of 43 checks, 43 items on a list of what does best practice look like in AWS. That's built into AWS Security Hub. That's going to allow us to get an idea of what are some of the things that we could maybe do better in our account. But in that example where a user's escalating their privilege, it's not a great idea if we wait until next week to check that and then say, hey, what were you doing last week? They've probably forgotten by now. Ideally, we don't just want to turn GuardDuty on. We don't just want to turn Security Hub on. We also want to alert on it. And what that will allow us to do is when that user escalates their privilege, we can ask them, what are you doing? Why are you doing that? Maybe you should be thinking about that in a different way. And once we're comfortable with how we respond to those alerts, we can also look at automating it. Perhaps when that user tries to escalate their privilege, we should disable that account until we've had a chance to talk to them. And so our security can scale because now it's all automatic. And again, these are tools that are cost-effective for us to use, and they're an efficient use of our time. GuardDuty and Security Hub both have a 30-day trial. So we can go turn those on, we can have a look at what sort of alerts they're going to give us, and then we can work out how to action them, understand what the cost is at the end of the month. What I've heard from other customers in Australia that are using AWS is that GuardDuty is typically less than 1% of their total bill. And out of that, they're immediately finding Bitcoin mining happening within their fleet. They're immediately finding ports that are open to the world that they didn't know were open to the world. And now we can look at, once we've got that foundational piece in place, we've got some monitoring on top of that, how do we build a secure application on top of that? Now, I don't know exactly what we're going to build for Pepper as a service, but I found this online. This looks like a pretty standard reference architecture of what a multi-tier web app could look like. And by using AWS, we have access to exactly the same cloud that NAB is using. And NAB are running a highly regulated exchange trading platform on AWS. They've already done the hard work to make sure that the right features are there for them to meet their security posture. Us as a small customer, we've got the benefit of getting access to the same platform as them. So as we're turning on these services, we can look at the documentation, we can look under security, we can understand the features that are there, and we can turn them on. For example, with CloudFront, we can use CloudFront to protect our different paths within our domain. We can either through signed URLs or with a signed cookie, so we can protect our content as it comes in. Our load balancer can sit within a security group, and that security group is like an instance-based firewall. We can ensure that the only traffic that can get to our load balancer is through CloudFront, and we can ensure that the only traffic that comes out of the load balancer is to our EC2 instances. When we're running within AWS, with Amazon EC2, we can assign a role to that machine, that virtual machine. So rather than a long-lived key and secret key, we can give a role to that machine that allows it to access AWS resources. So we don't have to have long-lived credentials in there. With Amazon S3, we can lock down the bucket policy and ensure that the only way that data comes out of that bucket is via the CloudFront origin access identity, and the only way that data can get into that bucket is via that EC2 instance. And then when we're looking at our RDS instance, our relational database server, we can ensure that that's in a private subnet. We can add a security group to that. We can also look at what engine are we running on top of RDS and ensure that we're implementing the right security features for that. And then once we've done that, we can look at what other services are available to us to be able to improve our security posture. For example, we can use the AWS Certificate Manager. Who here has worked in an organization where they've manually had to rotate certificates for their website? Who here has worked in an organization where they've had to manually rotate certificates for their website and it's worked reliably? That's what I thought. Certificate Manager integrates with the load balancer and it integrates with CloudFront and automatically rotates that certificate for us. We can also look at leveraging the AWS Key Management Service. That allows us to encrypt our data at rest in our S3 bucket. We can call it via an API if we need to further encrypt individual pieces of data before we put it in our database. And by using those two features, we've now encrypted all of our data in transit and we've encrypted all of our data at rest. But what does that look like? How can we use the features that are available to us to build something? One of those accounts that I spoke about in that multiple account structure is our security account. Or that's also, we sometimes also refer to that as a data bunker. And in our data bunker, I want to put all of our CloudTrail logs and lock them down. So if an incident should occur, we've got the right audit history there to be able to start looking through it. So is that all right? Might need to zoom in a bit. I've got my single sign-on portal here, which is going to give me access to all of my AWS accounts. And so the first thing I'm going to want to do is I'm going to think about how can I create a secure bucket for my logs that's going to be locked down. So if I go into my security account here, and I go to S3, I'm going to create a bucket and lock that down. What features are available to us in S3 to create that lockdown bucket? So apologies, it's a bit hard to see. You might just have to take my word for it that what I'm reading out is correct. When I create my bucket, so I want my a name for it, and then I can start to look at, as I build that out, what features do I want to enable? Well, I want to turn on versioning. That'll mean if somebody tries to overwrite a file, it's just going to create a new version. It's not going to remove the old one. There's an option here to be able to enable some default encryption in that bucket. The other thing that I want to turn on is this option here, Object Lock. This will allow me to permanently lock down files in this S3 bucket. This is what I was talking about before in terms of blocking that public access. We can apply that at an account level, but we can also apply that at a bucket level. For this bucket, we definitely don't want our audit history being made public, so let's block that now as well. And once I've created that bucket, I can now look at what other features are available to me. So if I go into that bucket and I look at the properties here, this is where I'm going to enable that object lock. So there's two modes there. I can either enable it in governance mode, which will allow me to overwrite files if I've got permission and I've got the right flag, but I actually want to enable compliance mode, and that means even the root user can't delete files within that bucket. So I think we should maybe keep logs for 60 days to start with. This is going to depend on what our organization policies end up as to how long we want that to be. But we can also use lifecycle policies to put that into lower tiers of storage and eventually remove those if we want to. So just confirming that, and I can lock that down. The other thing I want to look at is the permissions for this bucket. So within my bucket policy, this is how I'm going to say what's allowed to access this bucket. Here's a policy that I've prepared earlier. And I just need to make a few changes here, but I want to lock it down such that if you read this policy, it's saying CloudTrail is allowed to get the access control list for this bucket, so it knows it's allowed to read from it. And then it's also allowed to put objects into this bucket, so it can write those logs. So I can save that. Now, the next thing I want to look at is how can I enable CloudTrail for that? This is the root account for my organization. Which will allow me to navigate to CloudTrail, and I can turn on a trail. So I'm running out of time, so I'll just quickly go through this. But essentially what we're looking at here is when we create this trail, we want to ensure that we're giving it a good name, and we can turn it on for all regions. That means every region will be logged, and I can also apply it to the trail to everything within my organization. And I can put the bucket name in here and then apply it. Now, I'm running out of time, so I want to leave you with a couple of things here. The other thing we can do is we can apply policies to our organization to then prevent that from being turned off. Have a look at the documentation for AWS organizations. There's a bunch of example service control policies here, including number 1, prevent users from disabling CloudTrail. That's going to help us. And then the last thing I want to give you as well is that there's a number of resources available within the AWS documentation to help you. The well-architected framework and this best practices guide are a good starting point for us on our journey to understand what security features we can enable. And I've also put together this lab here. So on GitHub, we have a series of well-architected labs which can help us build well-architected systems. And in particular, this Quick Steps to Security Success lab, or Quest rather, is a collection of content that can help implement what we talked about today. So once I've applied that CloudTrail, the other thing I want to look at is I want to be locking it down so it can't be turned off. This is again going to be in that root account for my organizations. I'm just going to go ahead and copy this one. So this is, if you have a look here, it's very much like an IAM policy. It's going to deny anybody calling CloudTrail stop logging. And when I apply that as a service control policy, it doesn't matter if the person has permission to do that or not. The service control policy is going to prevent that. So I can create my policy here. So I can create that policy, which is now available to my organization, and I can apply that to my root account, which will apply to everything. The other thing we can do is when we go in and we look at these accounts, you can see I've put them in organizational units. So say I've got a particular compliance framework that I need to, that only has certain services enabled for it. Well, I could create a policy that's going to prevent us from using services that aren't in that whitelist and apply that to my application. But this one here, I'm just applying to my root, right? So I go through here, I can see my policy, and I can attach it. Some of the other example service control policies here that I think are a bit useful is we've got this one here, so requiring EC2 instances to be of a specific type. That's really useful for us in our development environment. We don't need massive servers in there, so we can limit it down just to running, T2 micros, for example, as this example here. So if we're going to deny running an instance if the instance type is not a T2 micro. We can apply that to our development environment to prevent our developers from incurring massive costs by launching the wrong instance type. And so just to wrap up, what have we looked at today? We've looked at how we can protect our root account. And by protecting our root account, because that root account is so powerful, we only want to be using it in break glass type situations. We've now got a user lifecycle. By federating our identity, we've got a user lifecycle for our users within AWS that aligns with the user lifecycle policy of our business processes. Because when somebody onboards, they're going to get an email. They're also going to get access to AWS. When they offboard, they're going to lose access to their email and AWS at the same time. We've implemented some basic guardrails by implementing those service control policies, by splitting out into multiple accounts and having separation of duty. We've also got some basic monitoring in place. And if we should have an incident, we've now got the forensics there, some basic forensics, to be able to do some diagnosis about what's happening from day one. So that's it in terms of the talk. If you have got any questions, I'll probably be chasing around the cars in the Deep Racer track this afternoon. Thank you.